Applications of differentiation. In this video, we are going to focus on maxima and minima problems. You will find this on page 292 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to succeeds. Maxima and minima problems. We will now look at some problems involving maximum and minimum values. For example, the manufacturers of milk containers often need to minimize the cost of manufacturing their product. To do this, they need to find the minimum amount of material required to make a container for a given volume. Other situations might involve finding the maximum area that can be enclosed within a certain shape. The first step in all of these problems should be to read the problem very carefully. Once you have done that, the next step is to identify which quantity is to be optimized and which is the constraints, the limiting quantity. One quantity will be clearly indicated as having a fixed value and therefore it must be the constraint. Once you have identified the constraint, the quantity to be optimized should be fairly simple to determine. Let's look at an example. A solid rectangular block has a base which measures 2x centimeter by x centimeter. The height of the block is h centimeter and the volume of the block is 72 cubic centimeters. Express h in terms of x and show that the total surface area A of the block is given by this. Let's first stop there. Given that x can, the volume is the constraint. It's only 72 cubic centimeter. So what is the volume of a cuboid? It's length times breadth times height. So put in the 72, put in the length, put in the breadth, and there's the height. Okay, now make h the subject of the formula, and I can even show you again here. So say it was 72. I think I'm rather going to use another color. Say it was 72 equals 2x squared h. It's just divide by 2x squared, divide by 2x squared. And it cancels, therefore h is 72 divided by 2x squared. Okay, now we start to minimize the total surface area. Okay, so the area is, now don't forget what is the area. I want to show it to you here. Say for example, it's you have length. I'm going to take another color again. You have length, you have breadth, and you have height. Now always do it like this. Take the first 2 and multiply it by 2. Then you take the, this was the first and the last. I want to use yellow again. The first and the last, and then the last 2. So it's the first 2, the last 2, and the first and the last, because you have 6 sides. Okay, that's the easiest way to remember that formula for total surface area of a cuboid. And now you're just going to substitute. You substitute all, okay, and there is your area, total surface area for formula. And now you have h, there's h, substitute it in, and then you have this. Okay, so find value of x for which a as given that x can vary. This was just the formula that I got there. Now given that x can vary, find the value of x for which a has a stationary value. So I'm going to differentiate. So if I differentiate 8x, and if I differentiate there, can I just show you again? I just like to, because sometimes due to the space, all the steps, but okay, can I just work on that last term? It was 216, and if the x came up, it was -1. If you multiply, it's -216, and then it is x to the power negative 2. So it's negative 216 over x2. Okay, so you differentiate the equation. Now for stationary points, dA over dx is equal to 0. So you put it equal to 0, okay? Then, again, just to solve this formula, I can again show you. Solving it. It was now just 8x. Take that one over, 216 over x squared. Put it over 1. So it was 216, 8x3. Okay. And then, this is what I got there. Do you see? And then I just divide by 8, divide by 8, and then I just take the cube root. And that is what I got there. So if I say 216, I just want to check. 216 divide by 8, it's 27. So it was x3 equals 27. And the answer was 3. Okay. Now, so that is the value of x. Now find the stationary value and determine whether it is a maxima. So find the stationary point. Okay, you can remember the previous videos. Okay, so let's just go on here. So substitute the value of x into the original equation to get the stationary value of a. So there is a. So if I substitute x, I get 108. Okay, there it is. So find the stationary value. It's 108 cubic centimeters. And now I'm going to differentiate again to find the nature of the point. It's 3, and if I substitute it in, I'm going to get that is a bigger, it's a positive number, so therefore it will be a minimum point. Okay, it's quite challenging. I think it's very good that you go through this again, that you even cover this, and that you try to do it on your own before you go to the examples, because the examples, it's a lot of steps and a lot of information and things to think of. And also, word sums, practical sums is also more challenging. So practice first this one before you go to the examples. Okay, but then after that, I want you to stop the video and I want you to do number 1 and I want you to do number 2. And let me just see, no, not number 2. Let's skip that one. I want the one with the open, the different, 3. And again, after you tried, after you did 1, continue the video, check to see if you are correct. And then do 3, continue the video again to see if you are correct. Okay, but I'm going to start. I'm going to start with number 1. Again, remember what I said? Read it and concentrate. Okay, it's a lot of information, but it's not so difficult. The base of a cuboid, okay, that has sides of length x and 3x. Okay, it's always good also to have almost like a picture. Can be very basic. So if I say 3x and x, okay, it's a cuboid, so it means there will also be a little bit of a height, or it will be 3-dimensional. There will be a height. Okay, the volume of the cuboid, I like to write everything in. So the volume is 288, and that is the volume. I think there's a mistake. I just have to correct it. That must be c cubic centimeters. Okay, so you can just correct it. Okay, now show that the total surface area is given by this. Now, let the height of the cuboid, let's start. I think, okay, let's say, let the height of the cuboid be h. Okay, So the volume, what is volume? Volume is length times breadth times h. Okay. Now what is the volume? It's 288. What is the length? It's 3x times x times h. Now make h the subject of the formula. So if I'm going to do that, I'm just going to divide by 3x squared, divide 3x squared. So the value of h is 288 divided by 3x squared. Okay. So now we're going to go over it and we're going to find the total surface area. Okay, now don't forget you have three values. You have the free, okay, it doesn't matter. Length times breadth. Okay, I don't want to say because that's volume. Length, breadth, height. So don't forget you have, I'm going to write it in, 3x, you have x, and you have h. Okay, so the total surface area, it's 2. Okay, I'm going to write it first. It's the first 2, so it's length times breadth, plus 2, the last 2, breadth times height, plus 2, the first and the last, length times height. Okay, now just substitute. Now length times breadth, so it's 3x times x plus 2, breadth times x times h plus 2, length times height, 3x times height. And that is going to give me 2, just keep the pen correct, 2, and that, I think I can simplify it further. Don't have to put in, because that's 3x squared times 2, and that will be 6x squared. That's xh times 2, so it's 2xh plus 3x, so it's 6xh. Okay, and that's what I get there. So if I'm going to simplify this, let's see, oh, this is xh, so this can simplify, do you see? So it's 6x squared plus 8xh. Okay, remember, it's addition and subtraction. Now, substitute, just like we did in the previous. Let's just put another color. Okay, so basically, if I'm going to do that, I'm going to get area equals 6x squared plus 8x 288 over 3x squared equals 6x squared. Okay, put it over 1. So the x cancel. So it's going to be, so it's 8 times, let's just multiply, 8 times, and that's divide by 3. Oh, it's nice. So it's plus 768. 768 over one of the x cancels, so it's just over x. Okay, so that is the formula. Let's see if it's correct. It's exactly what they wanted me to get. And then I go to B, go to white. Given that x can find the stationary value of A and determine its nature. So I'm sitting now with this formula. I'm just going to rewrite it. And then stationary points, what do we always first do? We differentiate. Okay, I'm going to get it ready for differentiation. Can you remember? You always bring the x up in the numerator. So basically, I'm going to get dA over dx it's going to be 12x minus, because it's going to be multiplying that, so minus 7, 7, 6, 8, and that's x to the power of 2, negative 2. Okay, now for stationary values, let's see. Stationary value of a when dA over dx is equal to 0. Okay, so I put a 0. Okay, I'm taking it up so that I get space. Okay, I bring this term over because it's negative. So I get 768 over x squared equals 12x over 1. I cross multiply, so 768 equals 12 x to the power of 3. I divide 12, okay? So 768 divide 12, it's 64. Take the cube root. And as soon as I take the cube root, I get 4. So therefore, what will be the value of x? The value of x will be 4. But now I go on. I hope it's still going to move up. Now I must find the nature of the point. So I'm going to double differentiate, or second derivative. So d square a over dx squared equals, and don't forget it's this formula. So it's just going to be 12. And if I multiply this with 2, but it's negative times a negative, so it will be positive 1,536, and subtract 1, so it will be x to the power negative 3, and if I bring it down, x to the power positive 3. Okay, and now I'm going to say when x is 4, d squared a over dx squared is equal to 12 plus 1,536 over 4 to the power of 3. So if I'm going to do that, 1,536 divide. Okay. 24 plus that 12. And that's going to be 36. And can you see that it's bigger than 0, so it's positive. So I'm going to say stationary value of a. Okay, so therefore it's a minimum. Therefore, minimum, because it's positive, minimum stationary point. But now I must still get the stationary value of a. Okay, I'm almost done. So there is stationary value of A, and now I substitute just that a value of X in that. Okay, can I just go up and down in the formula that you had there, in that formula? Okay, so basically it's just going to be 6x squared plus 768 over, and okay, over x. I didn't substitute yet, so it's 6, and it's going to be 4 squared plus 768 over 4, and my answer will be 288 cubic centimeter. It's quite a long sum, quite a long sum. Okay, let's do the next one. It's very good that you practice as many as possible because there's a rhythm. And you must get the rhythm of the sums. Just move it up. Okay, let's look at number 3. Okay, let's just get a pen. A rectangular tank is made of a thin sheet of metal. The tank has a horizontal square base. Okay, this is very important. It's a square. So it's a horizontal square base of side x and no top. Okay, very important, no top. When full, the tank holds 500 liter. It's the volume, 500 liters. Okay, let's start. Show that the area A of a sheet of metal need to make the tank is given by A. Remember, it's an open tank, so only 5 sides. And don't also forget, 1 liter is 1,000 cubic centimeters. Okay, let's start. Let the height of the tank of the tank BH. Okay, so the volume of it's actually side by side by side, but because of the height, okay, let's now I'm going to, this is also x, but this is going to be h. Okay, so it's going to be, let's rather work with length is base times height. It's going to give you the same. So it's just x, the base, it's just square at the bottom. But then I multiply with the h. So, and now I'm going to fill in the volume. But 500 liters will then be, multiply 1,000, will be 500,000 cubic centimeters. And that will be equal to, okay. Now I make h the subject of the formula. So I divide by, so therefore h is 500,000 over x squared. Okay, now I will come to the total surface area. Now, don't always write your values down. Then it's so much easier. Then it's the first two, the last two, the first and the last. And this is what I'm going to show you now. So it's the first two plus the last two plus the first and last. And that will give you then that, let me just see. I made a mistake. One mistake. Can you remember it's an open tank? So if it's an open tank, can you see? Sometimes it's good that I make a mistake so that because you're going to maybe make the same mistakes. So if it's an open tank, it means that this is only once. There's not a second one. That's why it's only x squared. So it's going to be x squared plus 4xh. Okay. Now I'm going to substitute h. So it's going to be, okay, let's just see, x squared plus 4x, and in the place of h, over x squared. And that is going to give me x squared plus, and now I multiply, so now I'm already at 2 million. And it's owing, this x cancel with that over x. Okay, and then I'm at number B. Where am I now? Find dA and calculate the value for which dA is 0. Show that this value give a minimum. Okay, so I'm going to differentiate. Remember, this is total surface area, but we can just write it as A. So I'm just going to get the formula first, just ready. Okay, so if I'm going to differentiate this, I'm going to get dA over dx is 2x minus 2 . Okay, so it is 2 million over x squared. So for the stationary values, value of A when dA over dx is equal to 0. So I'm going to, in the place, I'm going to put a 0. So I'm going to say 2x minus 2 million so 2x okay, and if I multiply this out, I'm going to do 2x3 is 2 million. So I'm going to get x3 divided 2 is 1 million. So x, therefore, x, take the cube root, will be 100. Okay. So what was the question? Show that this give a minimum value. So I have to move up again. Now, as soon as I want to find nature of points, I differentiate second derivative, d square a over dx square. Don't forget, it is this formula. No, not that one. It's this one that I'm going to differentiate again. So I get 2 because, and then I get, if I multiply, it's negative. No, a negative times a negative is positive 4 million. And if I subtract 1, it's x to the power of 3, negative 3. So if I bring it down, positive 3. Okay. And now I can say, what is that point again? If x is 100, then d square a over dx square 2 plus okay. Okay, and if I work out that, I will get exactly 6. And that will be bigger than 0, so it's positive. And I move up again. So therefore, it's a minimum value of A. Okay, and we are at the final one. Find the dimensions of the tank with minimum surface area. Okay, so we're almost done. Move up still a little bit. C, okay, I'm going to take another color. Dimensions of the tank, a square base, of side length. So the base is 100 by 100 centimeters. Okay, and the height of the tank just substitute in that height formula, and that will be, okay, what was the formula again? Oh, now a space. Height is equal to, it was that 500,000 square, and that would have given me 50 centimeters. Okay, that will be, so that's the dimensions of the tank. It's a base with 100 by 100. I can even move up the final step. So it was 100 by 100, and this was 50 centimeters. Okay, also try to do number 2. You will find the solution in the teacher's guide.